Okay, good afternoon. Right, sorry that I was not able to do the last week session also. Right, now we have done our syllabus, the big topics, all the topics. Now we have only two more topics to do, three more topics. Those are small topics, but from today onwards, I want to start your past papers. Okay. So we will be more focusing on the past papers, and while doing the past papers, we will do those small topics as well. So today I thought of doing uh, our first past paper, MCQ paper. So we will start with 2023. Okay, 2023. So then we will move on to 2021. Sorry, 2022, 2021. Still, I haven't got the official 2024 answer sheet. Once I get the answer sheet, we can do the 2024 paper as well. Okay, right, or the marking scheme. Uh, so therefore, we'll do the 2023 MCQ paper today. We'll do as much as possible. Okay, but of course, not questions related to the three topics we have not done. Okay, but all the other questions. Okay, right. So from next class onwards, make sure you attempt the questions and come so that we can do it faster. Okay. But we'll do at least 20 questions today and then we'll move on to e-business. Okay, if we have time. Otherwise, we'll continue with past papers. Okay. So after the MCQ paper, I will be doing the structured essay and essay paper also. So, right, fully finished 2023, then 2022 and so on. Okay, that is the plan. Right. So, and you can get a feeling of how prepared you are now, right? Because your exams are nearing. Right. So let's do one by one. So which of the following state, I will give little bit time today, but from next week, I'm not going to give you any time. I'll be doing the questions very fast because you should have attempted and come, right? So as I told you, we are going from 2023 MCQ structured essay, then 2022 MCQ structured essay, and likewise backward. Okay, right. So the question number one, and if you have any doubts, you can ask because you can't have doubts. Okay, when you go to exams, right? At any time, if you have any doubts related to any topic, any past paper question, you can tell me. And also, if you want me to do a particular past paper question little bit early, let me know that also because we can do. Okay, right. So there's no hard and fast plan from this class onwards. It's according to your needs, right? Which of the following statements are correct, right? Uh, So remember, you get 50 questions and 2 hours. That means 120 minutes, right? 120 minutes and 50 questions. So that means roughly you get about 2.5 minutes, less than 2.5, right? So just try to do within 2 minutes. Okay. And some questions won't take much time, especially the earlier part. But latter part questions like programming questions, uh, database questions, they take more time. So therefore, make sure the earlier questions you do fast. And if you don't have the past paper, anyway, the past paper is in Google Classroom as well. Okay. If you don't have the physical past paper, under past papers, the past papers and uh, marking schemes are there year by year. Okay. Right. So let's start with question number one. Which of the following statements are correct? Right? Which of the following statements are correct? Word processors and spreadsheet softwares belong to the category of utility software. Right? Word processors and spreadsheets are not utility software, right? Those are applications. Right? So remember, we subdivide computer as hardware, firmware, system software, and application software. So system software consist of OS plus system utility software, system utilities, right? So application software is some applications that we use. It can be personal applications or personal purposes or business or official purposes, like inventory management system, order processing system, e-business system, e-commerce system, or personal things like WhatsApp, okay, personal note taking, your contact management. So those are also application software. So the system software, you have the operating system and any other utilities. The utilities are not applications. The utilities include security utilities like virus guards, okay, then firewalls, some other utilities like defragmenters, file compression software. So those are called utilities. So those are not applications. We need those. It's like broom, knife in your household, right? So therefore, this is not a utility. These are application software. Compiler is an example for program translator. Obviously, yes. Right. So what are the program translators available? Can someone tell me? Because now we are going for the exams also. What are the program translators you know? Anyone? Because while doing the questions, we need to do a bit of revision. Anyone? What are the program translators? Program translator means your program is translated to a different format. No one? That means you guys are not yet ready for the exams. Right. So remember, if it is first generation language, 1GL, no need of a translator because we write it in machine code. Second generation, that is assembly. The translator is called assembler. So 1GL, no translator. 2GL, assembler. 3GL, that is something like Python, Java, C, C++. So we have either compiler or interpreter. And above also there are translators, but those depends on your language. So what are the translators? You must know. Assembler for 2GL, assembly code translation, compilers or interpreters for 3GL. 4GL also you need translators. Okay, so therefore compiler is an example for program translator. Correct. Okay. It is illegal to use proprietary software without obtaining licenses. Yes, not only proprietary software, any software, right? Any software you need license, even free and open source software. So that is why there's a free license agreement. So proprietary software, it's even severe. Okay, but any software you need license. Unless the software is in public domain, then you don't need license. Okay. Right. So therefore, it is illegal. Yes. So I'll go for answer as 5. 5. Yes. Answer is 5. Let me open this in a different viewer. Right. Right. Next question. So the answer is 5. Okay. Personal information of a system, students, and their exam marks are input to student information system. Marks for a subject range from 0 to 100. A student has to study a collection of compulsory and optional subjects and sit for the relevant examinations. Which of the following are suitable data validations for the above system. So in the very first day, your day one, we discuss about what is data, what is information, what is entity, okay, what is information system. So when it comes to information system, its effectiveness depends on two things. What are those two things? Correctness of the program. That is why we need bug-free software. Correctness of the input. So we call it garbage in, garbage out. So make sure your program logic is correctly written. That is why you have properly tested bug-free software, and make sure you don't allow invalid data, garbage into the system. That is how we can't prevent it 100%, but to some extent by using validations. And some validations client side you can do. Some validations are related to business, so those can be done in the back end. Right? Simple validations you can do in the client side. Right. So this is related to validations from day one. The presence check for the marks of all subjects taken, not taken by the students. Correct, right? But it says compulsory and optional subjects, right? Now we are in a little bit of a trouble because for optional subject, maybe the student may not have done a particular optional subject. Uh, then we are in trouble. So this question is little bit fussy. Now you can see the practical issues when you go for the exams. Yes, presence checks are good, but it looks like they have optional subjects also. So if you put up that maybe for compulsory subjects, present checks. Optional subject, don't present check means mandatory. Okay. But it says all subjects. That is little bit debatable, right? Because they talk about compulsory and optional subject, and your answer says all subjects. Okay. Uh, so in general, present checks are okay. Okay. But when you have optional subject, it's a debatable. Now, I'm not very sure about this. Right? It is not my problem because there are multiple ways you can look at it. Right. Anyway, let's look at the B. Range check to check whether an input exam marks is within the range of 0 to 100. That I will go for. Data type check to ensure that input made for the telephone number of a student contains only digits. Correct, right? Telephone number must contains only digits. But again, this question is not a very good question. Can someone say why? Can someone say, okay, if you are not going to take in this answer, what is your reason? What is your reason? Possibly if you don't want to go for this answer. Because when you write telephone numbers, we often use spaces, right? Something like this. Right. So then we are again in trouble. But theoretically, yes, telephone numbers can have only numbers. But people often use spaces also, right? Now, this is terrible question. Right. So therefore, it's not our problem actually. The examiner is very unfair setting this question. Okay. But anyway, we need to mark our answer. Right. Data type check to ensure that the input made for telephone number of a student contains only digits. I will go for like this. වැඩි පඬිත වෙන්නේ නැතුව ගත්තොත් මේක හරි කියලා ගමු. හරි ඕන රෙඩි හිතන්න නැතුව ගත්තොත්. Right. Presence check for marks of all the subjects taken or not taken by students. Now, here it says not taken also there. So if it is not taken, right, making mandatory is real issue, right? So therefore, so the good news is anyway they don't have an answer called ABC, right? ABC answer is not there. So therefore, I always need B, right? So I always need B So in these three answers, B is there, right? Okay. So then which one we want to go? Maybe we can go for B and C, or A and B, or only B. Right. Anyway, we need to take a decision. Okay, you guys also take a decision. I will also take a decision. It depends a bit of luck, not because of our issue. It's basically because the examiner is very unfair. Okay. Uh, by going by these names, it is correct. Okay. I'll go for B and C, taking a bit of risk because in life you need to take risks, right? Because life is not always fair. Right. I'll go for five. You may also think of your answers and let's see which one is the correct answer according to the examiner. But anyway, it's a terrible question. Right. So examiner has taken five. Examiner has taken five. Okay. Examiner has forget about spaces, possibility of someone typing spaces for telephone number. But examiner has really thought about some subjects are compulsory, some subjects are optional. So therefore, and also examiner has given another hint. You can see it says that all the subjects taken or not taken. Of course, if it is not taken by a student, how can we enter the marks? So therefore, examiner has given little bit of a hints to discourage students selecting this. So that is why I also did not take it. But anyway, examiner's answer is B and C. Right. Okay. So don't worry if you make a mistake in this kind of a question. Of course, try to be more realistic as well. But don't get too much frustrated about yourself, right? Because in life also, sometimes it's not your mistakes, others' mistakes. So then you think too much about that. So don't think too much about others' mistakes, right? So there are things under our control, there are things beyond our control. But don't make mistakes from our side, right? Our side. Right. Third question. The existing book management system in a school library is used with a computer, a monitor, keyboard, and a mouse. Okay, it's a book management system. A very basic hardware is used. The school management wants to minimize time taken presently for the book lending and returning. Which of the following is most suitable for this purpose? Right. So now you need to think. If you have visited a sort of a little bit modern library, you may have seen, but it's okay. Just use your imagination. Because I have seen some libraries and I have seen some of the gadgets they use. But maybe you may have seen it, you may not have seen it. Okay? Right. And again, it can be a little bit debatable, right? This kind of question. This is not a programming question to ask him what is 5 plus 2. Right. Using a digitizer, using an external hard disk, using a touch screen, using a magnetic stripe reader, using barcode technology. So what is your answer? Now they want to, anyone?
Barcode technology.
Yeah. So barcode technology is the most widely used. So what is the advantage of barcode? So then you don't need to enter the book number. You know that even that we use it in supermarkets. So they rather than they select whether it's pears, baby soap or signal medium, they just scan it, right? Which is much faster. So that barcode can be used to identify the book number. Yes, rather than you enter the book number or search by name or whatever, right? So magnetic stripe reader is not good because barcode technology is much easier, right? Otherwise, when you get a new book, you need to print it using special magnetic ink, that barcode, right? Therefore, this is too complicated. So these things are only used in where you need bit of more security like banks. Of course, external hard disk is not going to do any service for you, right? So touchscreen is good, but it's even better to go for barcode, right? Barcode. Digitizer is the general term, right? Digitizer is converting analog things into digital thing. In that sense, Even microphone is a digitizer, right? Touch screen is a digitizer. Writing pad is a digitizer, but uh, that is a very general solution, right? So therefore, more specific solution, and a lot of libraries already use this technology, the use of barcodes, right? Fine. Right. Fourth one. So your task is try to get the maximum, right? Again, some questions are unfair, so don't worry if, right, that is their problem. And if it is unfair, it's not only for you, right? For everyone. Everyone face the same question. So therefore, don't think too much, right? You just concentrate on your strengths. The fourth one. Listed below are some phrases about the internal operations of three printers. Printers. Right. By the way, this is 2023 paper. This is a very easy paper because this exam was held just after Corona, COVID. Okay, COVID. So therefore, and also we had economic issues, blackouts, so many problems at that time. So that is why so many questions from the earlier part of the syllabus. Okay, so don't expect this kind of paper anymore, right? But anyway, it's good that this paper cover a lot of early part of the syllabus. Right, listed below are some phrases about the internal operations of three printers. A moving print head striking an ink ribbon against the paper. So if it is an ink ribbon, that is impact printer, the old impact printers, which are very rarely used these days. Okay, because if it is a ribbon, not ink, that is impact printers, right? Impact printers. Toner, that is basically laser jet printers. Toner attracting to what is printed on a cylinder, which is then transferred to paper. That is exactly what happens in uh, laser jet printers, right? So you can refer to the input output devices note. Okay. Uh, right. So we did this under introduction to computer, right? Input output devices. Okay. So everything is mentioned. Right. See, nozzle spraying ink. So that is inkjet, inkjet printer. Okay. Onto paper, nozzle. So the inkjet. So the answer is first one must be dot matrix. Second one must be laser. Third one must be inkjet. So the answer is one. Straight from your textbooks. Okay. One. Question number 5. Now we'll little bit speed up also. Which of the following will, and if you need any more specific clarification, right? Let me know. I can explain. Which of the following will cause CPU to execute a different set of instructions? So that is an interesting question. So this is the really challenging question for some time, right? All the previous questions were very straightforward. Right. This is all about fetch, decode, execute cycle, compute architecture. Remember, fetch, decode, execute. One, right? Your program is loaded to the memory. So that means translated program, machine code, not the program you write, right? This is machine instructions, your converted code, right? So then first instruction is loaded, fetch to the registry, and relevant data is also fetch. And then, of course, relevant data might be fetched from another instruction previously. So then it is executed, sorry, decoded. When you decode only, it actually getting into the final machine code, 1-0 level code. So this is basically intermediate code, assembly code level. Okay. So then decoded into the machine code. So your machine code has operation code and operands like add this and this. Maybe these are memory addresses or register numbers. So then it is being executed in the ALU under the control of control unit. And then the result is written back to the registries. That is called fetch, decode, execute. So then the next instruction is loaded. It is decoded, okay, and executed. So likewise, your program is executed instruction by instruction until it's finished your processing, or you terminate your program, or there's an exceptional situation where computer cannot proceed with the execution. Okay, right. Now let's read it. Which of the following will cause the CPU to execute a different set of instructions? So different set of instruction means usually instructions from a different program, right? Again, the wording is not very good. So usually different set of instruction means instruction from a different program. So why? Yes, that happens, right? Because compute, remember we discussed on the operating systems, it does something called context switching. Give attention to process one bit of time slots. So then give attention to another process, another process, another process. Maybe now giving attention back to this process, and so on. So that is how computer try to execute them parallelly. But in reality, at a time, only one instruction or one program is run. But we feel like programs are parallelly executed because small time slots are given to these programs in a very short intervals. Okay. In that typical my computer. But in modern computers, for example, if when you have multi-core applications, right, dual core, octa core, sometimes different programs are executed by different uh, physical cores as well. Okay, right. So now let's read it. And even though you have dual core, octa core, still when you have two processors or two physical processors, still you are running 8, 10, 20 programs. Still you need to give attention to different programs. Okay. Uh, right. Now let's read the answers. Which of the following will cause CPU to execute a different set of instructions? Different set of instructions. The natural reason is context switching. That means OS has given the context attention to a different program. It has to do that. That is how the multitasking is done in single processor environment. Second one, interrupt. That is also possible, right? If when there's interruption, like the user has stopped the program, hold the program, pause the program, it's interruption. So then, of course, operating system will give attention to a different program because it's interrupted. So I'll go for that toast. Because when a program is interrupted, it needs to give attention to another one because no point giving attention because it's interrupted. Third one, user selecting the shutdown operation in the computer. That is also correct, right? So when the user decided to shut down, if you have been running some other programs, now all of a sudden you need to terminate these programs, and also now the operating system must also be given time slots more because operating system is the one that doing the shutdown. Right? So when you immediately say shutdown, definitely your context switching will also again happen because it's now busy terminating the programs rather than finishing. For me, all are correct. All these things can result in executing different instructions. But my major answer is A. Major answer is A. Right? So A only is also there, but for me in general, all are correct. All are correct because in all these situations, there's a possibility of context switching. So therefore, I'll go for 5. I don't know whether the examiner will go with the best one. Okay, but I'll go for 5 because for me, all these are possible reasons for executing different set of instructions. I'll go for 5. Yes, examiner also has taken 5. Now you can see that this paper is not difficult. This paper is fuzzy. Right? So there are two ways you can make things difficult. One way is genuinely ask difficult questions, challenging questions. Second way is make questions fuzzy. Okay. So this is little bit fuzzy question. Okay. By the way, this is not very bad question because you must know that in all these situations, there's a possibility of context switch, possibility of giving attention to a different set of instruction, right? So only thing is you must have thought of these things in a serious manner. That is called studying rather than just memorizing. So that means you need to talk to yourself, right, about how the computer process data. Right? Now that is called studying. Studying is not taking someone's, of course, in our case, I have given you some notes, maybe your school teachers, other books. Studying is not reading others' notes. So those are to help you guys, guide you guys. Studying is you question yourself, right? You question yourself, right? You argue with yourself. So that kind of students will find these questions not that difficult. Right. Question number 6. The program runs fastest when the data it requires are in the right. What is your answer? Remember, memory is a hierarchy. We look at the storage hierarchy. Okay, so one part of the storage is in the processor itself. We call it registries. Then cache. Cache we can subdivide into 3 levels: L1, L2, L3. L1 and L2 is in the processor side, not inside the processor side. L3 is in the motherboard or memory side. But registries are inside the processor. L1 and L2 is just outside the processor. L3 is just outside the RAM, but it is closer to the processor. Then you have the RAM for main memory, right? Main memory. Then you have the secondary storage, so SSD, and then you have the tertiary or backup storage, like CD, DVD, pen drives. And we discussed those, introduction to computer. Program runs fastest when the data it requires are in the hard disk, magnetic tape, L1 cache, main memory, L2 cache. What is the answer?
L2 cache.
Why L2 cache?
The L2 cache is very the fastest and
Which one is closer to the processor? L1 or L2 or L3?
L1 and L2 are in the process.
L1 is the closest, right? So that is how I wrote like this, right? L1, then L2, then L3. If something is closest to the processor, right?
It must
Something
be
is
the
closest to the processor, that is the fastest. So
okay,
therefore,
sir.
registries are the fastest because registries are inside the processor or ALU. So then L1 is the fastest because processor is the fastest guy. So therefore, processor need something that act very fast. So therefore, fastest to access is registries, but registries are not in your answer. Therefore, you can't take that. Then the L1 cache, then the L2 cache, then the L3 cache, then the RAM. Okay, then the RAM. So therefore, out of these questions, out of these answers, right? So you need to go for L1 cache. L1 cache because L1 is if it is not in L1 only, it will check the L2. If it is not in L2 only, it will check L3. So therefore, obviously, your computer will first look at your L1 cache. Okay. And of course, because it's closer to the processor means faster. Okay. So therefore, I'll go for L1 cache. Okay. Let's see examiner's answer. 6. Yes, L1 cache. Is it clear? Right?
Yes, sir.
So the closer to the processor, so basically when you go up the hierarchy, it's getting faster and faster. Okay. And storage is getting small and small as well because you don't need a lot of storage because registries, you just need current instruction and related data and so on. Right. Seventh question. Now, when we do about 2, 3 papers, so entire syllabus will be revision. Okay. What is the correct binary equivalent for this? That is very easy question if you know your theory, right? So how to convert this? Separately convert, right? Whole number part, keep divide by 2. 6, 1, 3, nothing, 1, 1, 0, 1. That is 1, 1, 0, 1, 0, 1. Then decimal part, you keep multiply by 2, right? 0.125 multiplied by 2, 0, 5, 2. Then take that because it's not 0, 0.5, still it's not 0.
Third answer.
0.5 into 2 is 1.0. Now we can stop because we got 0. Now you need to write this whole number part from top to bottom. Here, bottom to top. That is why 1101. Here, top to bottom. It is 001, right? 001. So the answer is 1101.001. Yes, third one. Right? Anything not clear that you need any clarification? Because this is the good time to get your clarification because now you need to start asking questions. Right? So the answer must be third one. Third one. Right. Eighth question. Which of the following are equivalent to octal 674? So binary numbers, octal, the binary, hexadecimal. So you need to check all three now. Right? You need to check all three. It's a time consuming, but so that is why you need to do those other questions very fast.
B and C.
Okay, so let's see. 0.674. I will first convert it into binary because that is the easiest. Anyway, I need to check all three. So how to convert it to binary? Octal number. Convert each octal number into 3-digit binary.
If binary.
3-digit binary, right? So therefore, let me erase this. I will start with the easiest, that is convert to binary. So 6 is 110. 124, 2 plus 4 is 6. 7 is 111. 4 plus 2 plus 1. If you can't, you can just keep divide. Okay. 4 is 100, 124. So therefore it is 110, 111, 100. A is correct. A is correct. So therefore these are not answers. Right? This is not answer because A is correct. Right. Now I will convert this to hexadecimal because it's easier for me. How to convert because I am going to convert binary to hexadecimal. Right? Here octal to binary. Now
Divide into
binary to
four
hexadecimal.
parts.
How do you do that? Break it
Divide
in,
into four binary.
yeah, chunk of 4, starting from the left end. So therefore, I'll again write this 110, 111, 100. Now I'm going to break it into chunk of 4 from the right hand side. So then 1, 2, 3, 4, 1, 2, 3, 4. And convert this into base 10, but write it as a hexadecimal digit. What is this? 1, 2, 4, 8. That is 12. 12 means 10, 11, 12. A, B, C. So this is C. What about this? 1, 2, 4, 8. 8 plus 2 is 10. 10 plus 1 is 11. 11 means B. Okay. And this is obviously 1. So therefore it is 1BC. Right? 1BC. But this says 2BC. So therefore this can't be correct. So C is not answer. So therefore, this is not answer. This is not answer. Okay. But now you need to check whether B is correct because A only is there, A and B is there. Anyway, we need to do that. Okay. Right. So now we want to convert it to base 10. It's easier for convert me to convert binary into base 10, or you can even octal also there. Okay, shall we convert the octal then? 6, oh, yeah, 674. That is 8 to the power 0. So ones, 8 to the power 1, no, 8s. 8 to the power 2 was 60. 64. So 64 into 6. 6 into 4 is 24. 2, 36 plus 2, 38. And 8 into 7. 8 into 7 or 7 into 8. 56, right? 56. And 4 into 1. 4. 6 plus 4, 10. 10 plus 4, 14. 1. 9 plus 5, 14. 1. 4, 4, 4. So therefore, I'll go for A and B only. That is, I'll go for 2. Right? It's time-consuming question, right? But it's a good question, right? It check whether you can convert all these conversions, okay? Right. 8 must be 2. Okay. And if you are not very sure, you have the recordings. If you cannot access any of the recordings, let me know. Right. I will double check whether you have the access or not. So this should be somewhere recordings, maybe. Yeah, somewhere around 10 or something. Right. 10 to 15. Okay. Somewhere here. Okay. Somewhere around 10 recording or something. Okay. Uh, if you are not very sure. Right, next one. So these are easy questions, right? Now we have sort of a easy questions if you know your subject. I mean, not fussy questions. The address of an instruction was shown as 5A1 in hexadecimal. We don't care whether it's an address of an instruction or whatever. This is a number conversion question for us. Right, 5A1 in hexadecimal. What is the address in decimal? So it's super easy, right? 5A1, 16 to the power 0 or 1, 16 to the power 1 or 16, 16 to the power 2 or 256. 250, is it 256? Yeah, 256. So we have 5 256. 5 into 6, 30, 3, 25 plus 3, 28, 2, 10 plus 2, 12. Then A means 10 into 16, 160. And 1 into 1, 1, 14, 4,441. Answer is second one, right? Ninth one, answer is second one. Second one. Right. 10th question. Again, now it's representing data in computer. So far, it's number basis. Document contains 2048 characters, including spaces and line breaks. Spaces and line breaks are also characters. Everything is a character. Okay. Even tab B is a character. How many bits are needed to encode this document in ASCII, also using parity bits, right? Also using parity bits, right? So remember, ASCII use 8 bits and 1 bit was used for parity, remember? So remember what is the difference between ASCII and EBCDIC? ASCII 8 bit, but 1 bit is used for parity. So therefore, every character need 8 bits. Okay. In EBCDIC, every character again needs 8 bits, but all 8 bits are used, though therefore the range is bigger. Still, every character uses 1 byte or 8 bits. Both ASCII and EBCDIC, one character use 1 byte. But the advantage of EBCDIC is EBCDIC support twice the number of characters than ASCII. Then, of course, these days we don't use ASCII much. We use Unicode. Sometimes it's 4 byte, 8 byte, depending on type of character you use. Because we need to support bigger range, like Sinhala, Tamil, Chinese, Japanese, Hindi characters. Right. So what is the answer now? Every character take 8 bit because ASCII using parity bits. So 7 bit plus parity bit. So therefore my answer is 2048 into 8 because every character take 8 bits. Okay. This is the same for even lipstick. Again 8 bit. 8 bit. So I'll go for 4. Is it clear?
So what is that parity bits? Is that mean
Yeah,
that
parity bit
even
means,
parity,
yeah,
even parity, odd parity?
yeah. So the parity bit means now this ASCII table was introduced in 1950s, where the computer was evolving. Computer was evolving, right? At that time, computers were not very stable. So therefore, when you transmit data from say hard disk to uh, memory or memory to the processor or something like that or transmission. So these bits tend to corrupt it. So maybe we are sending something like this, but maybe what we receive is 100000111. This bit has been corrupted. This bit has been corrupted. Even today that can happen, but very rarely. But at that time, this 1950s, this kind of corruptions were pretty normal. So therefore, when they came up
Excuse
with
me, sir.
the ASCII code, so they allocated 7 bit for the ASCII code, 7 bits, and reserved 1 bit to detect possible error. Okay, detect possible error, but it doesn't detect all the errors. It can detect some errors. So therefore, this is not a perfect solution, but something is better than nothing. So therefore, they reserve the last bit for check whether this kind of changes or corruption has happened to the your bit, your data. And that is why the last bit was marked as or considered as the parity bit. Right. So how it works? It's very simple. Say your actual data is say 10011000, right? Just 7
Excuse
bits. Yes.
so the parity bits, the parity check works on only for 8 bits.
Sorry. Yeah,
The
parity bit is including the parity bit, it is 8 bits.
Okay, then parity check, we use parity check only for 8-bit
At,
numbers, right?
at that time,
Oh,
ASCII. Okay, so it has been changed since. So now I'm talking about original ASCII representation. Okay, original
oh,
ASCII representation. Actually, these days we don't use this parity bit anymore, right? At
mm,
each byte level because we don't need parity bit for each and every byte. But this is good old days ASCII. Good old days ASCII. That is
oh,
what they say 7 bit plus parity bit. But these days, entire 8 bit is used. But this is according to the question, because question says 1 bit is used as parity bits. Actually, that is how it was first introduced. Right. So therefore,
oh,
say this is my data. 7 bit. Now, the 8 bit is decided by how many ones are in your 7 bits. If that is your data, right? First 7 bit is your data. Now, in this case, we have 1, 2, 3. We can go for either even parity or odd parity. It depends on your.
So
It's
do we have to add the if there are error in that number, binary number, we have to add the one at beginning or at the end?
error means
If they are, when we checking on even
just just
uh,
just just wait until I finish my explanation. Then you can ask that question. Okay.
oh, okay, sir.
Right. So after my explanation, you can check whether your questions are now answered or not. Okay. Right. So at that time, what happened was, so we use the first 7 bit only for data. So the last bit is or was reserved as the parity bit. Parity bit. And there we can use either odd parity approach or even parity approach. Right? If we go for even parity approach, the idea is you must have even number of total ones in your 8 bit. Right? So here we have already 1, 2, 3 ones. So therefore, remember, if it is even parity, you must have even number of ones. So therefore, you need to add this as 1. Okay. Say this is another example. 1, 0, 0, 0, 0, 1, 1. Sorry. Let's say this is also 1. Now what should be the parity bit? This is my data. 7 bits. 1, 1, 0, 0, 0, 1, 1. You can see already I have even number of ones. Even number of ones. So therefore I should not add another one. Then it become odd number. Say we go for even parity now. So then this must be 0. So likewise, your parity bit can be either 1 or 0. 1 or 0. If you go for even parity, how do you decide whether it's 1 or 0? Make sure that your total number of ones is even. But if you go for odd parity, you add your 1 or 0 to make sure that your total number of ones is odd. That, of course, you need to know or you need to decide. Right? Now, how do you find any issues when we have the parity bit? Because the purpose of parity bit is detect possible issues. Now, assume during transmission or during storage or whatever, let's assume so this 0 has corrupted to 1. Now, this is what we got. Now, when we receive a 1 byte of data, we check the parity. But we must have agreed whether it's even parity or odd parity. Now, assume we have agreed that it is even parity. Now, this is what I got. Okay, this is what I got. And now I will check how many ones are there. 1, 2, 3, 4, 5. So, if it is even parity, you can't have odd number of ones. If you got odd number of ones, that means maybe some of the bits are corrupted. Not maybe, definitely some of the bits are corrupted. So therefore, you can reject and ask, resend that data because something wrong with this byte of data. Okay. But say you got it without any corruption. That is, this one is 0. Sorry, this one was 0. Now you can see 1, 2, 3, 4, even number of ones. So therefore, you accept it. Right. So therefore, while counting the parity bits, so by counting the ones, not by looking at the parity bit, by counting the ones, if you go for even parity, we accept the data, that byte of data, if we have even number of ones. If you have odd number of ones, we reject that byte of data saying it is corrupted. That is if you go for parity or even parity. If it is odd parity, when we receive 1 byte of data, we check whether we have odd number of ones. Then we accept. If we get even number of ones, then we reject. Okay. So in this approach, right? In this approach, we can't detect all the problems, but we can detect some problems, right? Some problems, some corruptions. So therefore, this is very primitive approach. So there are more sophisticated parity bit techniques to detect even more errors. That means increase the type of errors that you can detect. But in your syllabus, simple parity bit check is there. That is, just add your last bit 0 or 1. If you are going for even parity, make sure you add it so that total number of ones are 1. If you use odd parity, make sure to add your 1 or 0 to make sure you have odd number of ones. So then when at the other end or when you receive it, you double check the same logic and you can decide, you can either accept that or reject that data. Okay. Now
Very
this can
basic.
detect some problems, but this cannot detect all the corruptions. So what kind of corruptions that this simple parity bit cannot detect? Can anyone tell me? Use your common sense, logical thinking and tell me what kind of errors this simple parity check will not detect. A possible example. Or this one bit parity check will not detect, even though the bits are corrupted.
They are more than
Yeah,
8.
so definitely, if more than one bit is corrupted, right? But not all the time, sometimes. For example, now this is our, we are preserving even parity 1, 2, 3, 4. And if one bit is corrupted, we can detect. But what happens if two bits are corrupted? Say this one becomes 0, this 0 become 1. Now two bits are wrong, but still I got even number. Or two of the bits are changed from 0 to 1 or 1 to 0. Or one change from 1 to 0, other one change from 0 to 1. So that kind of errors are not detected. That means if you have odd number of bit corrupted, it is detected. But if you have even number of bits corrupted, those are not detected. So that means this only detect about 50% of the errors, right? So this detect about 50% of the errors, but other 50% of the errors are not detected. That is where people came up with even better parity mechanisms. Okay, but that is beyond your syllabus. And the number two is, these days we don't need to check parity for each and every one byte because these days errors are very rare. So these days we check, still we have parity bits, but for large number of bytes we have set of parity because errors are rare these days. Okay, right. Now, do you have any question?
Yes. So the reason why I asked is that
Yeah.
my school teacher said to add the parity bit at the beginning.
No, it depends. Whether it's beginning or end is depends on your mechanism. Okay. It depends on the mechanism. So
And he
usually
said,
parity is added to the end. Okay.
okay,
Because this parity is added to different things. Maybe it's a data packet, right? So there are different places we add this parity bit, and this happened in 1950s, 60s. These days we don't add this parity bit anymore at byte level. So therefore, this happened in 1950s, 60s, adding parity bits to the each and every byte. So therefore, it doesn't matter, right? It doesn't matter whether it's beginning or end. Only thing is you need to add a parity bit to detect whether it's corrupted or not. Okay,
okay, so
right.
got it.
So
Thank you, sir.
therefore, anyway, this question doesn't check whether you know where the parity bit is, right? What is the purpose of parity bit? It just check whether you know whether ASCII or early days of ASCII use 8 bits. That's it. Because that is what they represent in data in computers syllabus is interested rather than parities and those things. But you must know that at that time it was 7 bit plus parity bit. Therefore, each character took 8 bits. 8 bits. But pretty soon they get rid of that parity bit and went for the stick, where all 8 bits are used for data. And then they moved into the Unicode as well. Right. Our next question. So this is also related to representing data in computer. Right. It's about how to represent whole numbers in computer. Remember how do we represent whole numbers in computer? Modern computers? Two's complement approach. Right. Two's complement approach. Right. How to represent minus 49 in 8-bit two's complement. So that is super easy. First convert 49 into binary. 2, 4 remain the 1. 12 remained 1, 6 remained 0, sorry, 12 remained 0, 6 remained 0, 3 remained 0, 1 remained 1, 0 remained 1. Right, so the number is 110001, right? Because it says 8 bits, right? We will fill with zeros. 1, 2, 3, 4, 5, 6, 7, 8. You can double check also. This is 1, 2, 4, 8, 16, and 32. 16 and 32. 6 plus 2, 8 plus 1, 9. Yes, 39. Yeah, 49. Correct. So, right. So this is plus 49. So what we need is minus 49's two's complement. So how do you convert negative number into binary? Two's complement. Take the bit pattern for the positive number, then swap bits at 1. So therefore now we can swap bits.
So we have to change it into one's complement.
Yeah, that is what is meant by swap bits. So swap bits is one's complement. Okay. So we swap bits and add 1. So swap bits 11001110. That is your first step, one's complement, then add 1, then it is two's complement. 11110011. And that is your two's complement for minus 49. So 111100 4 ones. 1100 4 ones. Answer is fourth one. Any questions about that? Okay, no questions. Right, 12th question. Now we are into the logic gates. So we have a NAND gate. NAND gate. Consider the logic circuit in which X indicates two input logic gate. So that means this is another gate. Okay, another gate. Uh, which of the following should X be so that A equals 0 and B equal 1? The output would be 0. So the output would be 0. Then what should be this gate? Okay, so that is a question. Multiple possibilities are there. You can see 1 and 2. So therefore, the only way I can do this is uh, have this gate here and check what is the output. And if you get 0, that is a correct answer. Okay, right. So therefore, because it says what should be your X, right? So therefore, this is my, anyway, this input is 1.0 is 0, 0 bar is 1. So then I don't care this. I'm only interested in this. Okay, I'm only interested in this. That means when I get 1, this I should get 0. So that means it must behave like a not gate. It must behave like a not gate. I know that how to create a not gate using NAND gate. But forget about that. Say this is my NAND gate. I'm just checking whether the first one is correct. Because I know that I am getting 1. Because right, 1. So then this is 1. 1.1 is 1, then not 1 is 0. So therefore I get 0 here. Yes, so then I get 0. If it is an AND gate, I get 0. So this is correct. Right? So can it be a NOR gate? Let's see. Can it be a NOR gate? If it is a NOR gate, it is like this. But this is FET. Because, okay, this is O and NOT. Right. So then 101 is 101 is 1. Then when you NOT it, 1 becomes 0. Yes. So again we get 0. So no is a possibility. Then what about XO? Right? XO means so there's no not here, but now it is something like this. XO. If it is XO, 1 XO 1 is 0. Remember in XO, when different you get 1, when same you get 0. Now same input, both 1, right? Both 1. 1 no 1 XO 1 is 0. 1 XO 1 is 0. And yes, what we need is 0. Right? So therefore, that is also correct. That is also correct. So therefore, any of these will convert this into 0. I'll go for 5. Answer is 5. Is it clear, or do you want me to explain it again? Or you have any doubts or questions? Anyone?
No, sir.
Because if you have any questions, you need to ask, okay? There's nothing called stupid questions, right? Every question is valid. Right. So now we'll move on to our next question. Which of the following is the simplified form of Boolean expression x bar plus y? Now this is where you need to remember those. I gave you 23 rules and asked you at any time you must be able to write those rules, right? If you need discuss, if there's a situation for that. So can you guys now write that? I can write. I have no doubt about that. Anytime I can write it because logic is, by the way, my favorite subject. I told you these are the most important rules for me in the world, nothing else, right? Even some mathematical rules, I don't care as much as this because all the time I think, all the time I process logic, I process mathematics, right? Trigonometry very rarely. So therefore, I love these rules. I know how important these rules. Okay. Let me write down the rules so that say you can also take a piece of paper and write down. This is my first rule, single rule. A bar bar is A. Then we have the duals. Of course, I can write 1 bar is 0. 0 bar is 1 also. Then I have A dot B same as B dot A. A plus B is same as B plus A. Now keep writing duals. Then A dot B dot C is same as A dot B dot C. Uh, A plus B plus C is same as A plus B plus C. Then I like to write the distribution law, or you can simply write this A, B, C because bracket has no meaning, or A plus B plus C. And so the distribution A dot B plus C is A dot B plus A dot C. It's dual. A plus B dot C is A plus B dot A plus C. Now already how many rules? 2, 4, 6, 8, 9. Right? So almost half. 6 one is my favorite, De Morgan. A plus, sorry, A dot. I usually write the dot one first. That is also to make sure that I am writing it in a very systematic way. Right? So usually I write the dot rule first. but that is not a must. Okay, that is my preference. Therefore, I'll write the dot rule first. A A dot B dot C bar is A bar plus B bar plus C bar and so on. Its dual A plus B plus C plus bar is A bar dot B bar dot C bar and so on. Now I want to play A with A bar, A with 0, A with 1. That is how I remember. Okay. And seventh, A dot A is A. Usually I write the dot rule first and then the dual. A plus A is A. Now A with A. Now A with A bar. A dot A bar is 0. A plus A bar is 1 because I know that when this is 1, this is 0. For AND gate and logic, both must be 1, but always one value is 0. And here, at least one must be 1. Always one value is 1 because when this is 0, this is 1. So likewise, I can explain. Right now, play A with A bar. Now I want to play A with 0 and 1. A dot 0 is 0 because in AND gate and logic, when one value is false, the result is false. And in OR gate or OR logic, when one value is 1, regardless of this output is 1. Because getting one value 1 is enough to make the output 1. So you can say I write it with some purpose. I'm not just vomiting like buffalo. So then I know that there's another possibility of playing with 0 and 1. That is A dot 1 is A plus 0 is A. That is same, but rather than playing with 0, now play with 1. And I get the same because when this is 1, 1 dot 1 is 1. When this is 0, 0 dot 1 is 0. This value is repeated. Okay. Right now we are into the final set of special rules. This is my favorite. A plus AB is A. These are single rules actually. Of course, we have the dual, but we are not interested. Next one is also very interested. A plus A bar B equal A plus B. Next one is converting XO into other gates. A XO B is A B bar plus A bar B. And final one is A plus B dot C plus D is like algebra. AC plus AD plus BC plus BD. So I know that there are 23 rules here. Right. So that is very important for my confidence. I never know which rule I will be using, but I'm pretty sure using those rules I can solve any question in your AL-ICT. Not only this, your second paper questions, logic question. Right, now let's look at this. Which of the following is the simplified form of Boolean expressions? Right. First, I will be applying the distribution law. Right, because straight away I can see possibility of distribution law is there. Right, so therefore I write this as, because X bar and Y, there's no rule like that. Right, there's no
Excuse me,
rule
sir.
for A plus B bar. Okay, that is why I start with a distribution rule. Okay, so then I will take it as X dot X bar plus X dot Y. And I know that A dot A bar is 0. Because in AND logic, when this is 1, this is 0. When this is 0, anyway 0. So therefore this is 0. Right? So that is our logic. A dot A bar is 0 is one of the rule. Right? So but which rule is that? This rule. Right? A dot A bar is 0. So therefore this is 0 now plus XY. And remember something plus 0 is but something plus 1 is 1. Something plus 0 is same thing. Which rule is that? Something plus 0 is, if you take this as a block, it's like A plus 0. So A plus 0 is, right, A plus 0 is A. So therefore that block is, you just write your block. So therefore x5 plus 0 is x5. And I can't process, there's no rule to simplify this. So therefore, I'll settle for x5 as the answer. So answer is third one. Right? Answer is third one. Any questions? Any questions? Anything that you need to clarify? You need clarifications? Right. So when you have free time, take a piece of paper and write and see whether you get the 23 rules. Okay. You can write whatever the order, but try to organize it right nicely so that you have better chance of remembering. Because then you can see the patterns. Right. Next question. A program in execution in a computer is called processes. Running programs are called processors. We discussed that under operating systems. Which of the following is a possible state transition sequence of such a process? Possibility, right? Now remember, now of course, if you can remember the process diagram, it's super easy. Otherwise, you use try to survive with whatever you can remember. Of course, if you like subject now, you must remember. Okay, you must remember. Uh, of course, I can remember. Right? For example, it first it is in the new state. So then it goes to ready state. Ready means ready to execute. So then your processor will take it to the running and getting back to ready because your time slot is over. Again running when you are given time slot, right? If you can go from this to that, that to this many times. And when your program is fully completed or user has terminated or due to exceptional situation you can't proceed, so then it is going to the terminated or end or whatever. Terminated, done, right? So then there are some other possibilities. That is, maybe while you are in the running state, you go to the block state. Block state. Why do you go for block state? Can someone tell me what is the possible reason for block going from running to block? Anyone? So why others are very silent?
Timeout.
Yes.
Even
Yes. What is the reason?
timeout.
Timeout. No, that is not correct answer. When it is timeout, it goes to the ready state. My question is, what is the possible reason for going from running to block state? You can see block state.
The enough information is not there.
What do you mean by enough information is not there? Maybe your answer is correct, but it is not direct answer. Therefore, I just want to clarify whether you tell me the with that in your mind. Yeah, waiting for input to output operation. So if you are waiting for input to output operations, now the screen is displayed, but the user need to enter something and submit, something like that. So that can happen. Or maybe there's a confirmation box and user need to confirm. So in that kind of situation, nothing to run. So then that process is put it into block state until user give the attention. The moment user give the attention, right? Or the user now does this input operation or the output operation, or basically input operation. Now can it come back to running state? No. Once it is in block state and that operation is done, it must come to the ready state. It can never go back directly to the running state. Those are the things you need to understand. Okay. And then when you are given a time slot by the operating system, you can again go back to running state and again come back to ready state and so on, depending on the time available. Okay. But in this question, they have referred to only these states, but in reality, there's another state. There are two more states. But this question can be done using only this. So therefore, let's do the question because this is enough for this question. Right. Can it go new, ready, running, terminated? Possible, right? From new it goes to ready. From ready it goes to running. Running it goes to terminated. Yes, that is possible. Can you go from straight away from new to block? No, you can't directly go from new to block. So that is not possible. So new to ready, yes. Ready to block, no. You go to the block state while you are in running, not in ready. But when you are in block state, you are coming back to ready. So therefore, this is not possible. Right? New to running, you can't go. There's no way you straight away going from new to running. You need to come to the ready and the scheduler must put it into running. So this is not possible. From new, you can't straight away go into block. So therefore, answer is 1. 14 answer is 1. Okay. Now, what are the two other states? So we have two more states, right? That is
Ready,
ready.
suspend,
Yes, ready,
suspend,
suspend. Other one, block
block,
suspend.
suspend.
Yeah, block suspend. So how can that happen? Say you are now waiting for running until you are getting the time slot. But by that time, while you are in that state, your operating system decide to, okay, we are running out of memory. We want to put this process into the virtual memory or the secondary storage because it needs to load another program. So then it is taken from ready to ready suspend. That means your process or the content or memory related to that program or part of that program is in the virtual memory, secondary storage, not in your main memory. So therefore now you can't run until it's taken back to the memory. So you are taken to the ready suspend. And when that memory is available, operating system will again take it back to the ready. So it will take it back to the ready when that memory is taken from virtual memory to the memory. Okay. So that happens while you are in the ready state. But then memory issue can happen while you are in the block state also. So now we are waiting for input operation. But because of the lack of memory, operating system has decided to put that part of the memory into virtual memory. So then you are going from block to block suspend. Block suspend. Okay. And assume that now that memory issue is resolved. Memory issue is resolved, but still the response has not come from the user. So then you can go back to block state. Block state. Because now the memory issue is resolved, but still the input hasn't come. Or else, while you are in block suspend, right? Now the user has responded, but the memory issue is still there. So therefore, you can't go to ready. But now you are not blocked. So then you go from block suspend to ready suspend. So then when the memory issue is resolved, you will be taken back to ready. Okay. So that is called the process transition diagram, right? Process transition diagram. But this question has not referred to this part, right? It has not referred to this part, but it just happened in that paper, right? Because in your paper, sometimes they will ask, second paper, they ask you to draw this structured paper. Draw this and explain. And sometimes you need to identify missing labels like X, Y, Z. And also you better know the words for these activities, right? Okay, words for these activities as well. Those are given in your note. Okay. Right. Question number 15. Amara powers on the computer and start a spreadsheet application. Right. Spreadsheet application. Then he also opens a web browser. It's maybe something like Excel, and now browser is also running, like maybe Firefox, Chrome. Which of the following are possible execution sequence of the processor of of his computer? Okay. Again, this check whether you know how the operating system run your programs using context switching. Now, definitely OS is running, spreadsheet application is running, web browser is running, and possibly some other programs are running. Okay. So it says power up, sorry, Amara, power on the computer. So when you power on, what is the first thing happen? First, your firmware will do the power on self-test, post-test, and then once it double check whether all the components, essential components are working, so then it will boot up the OS, and give the control to the operating system after OS is loaded. From that point onward, OS control the running. Okay. So therefore, obviously the first step is BIOS. There's no doubt because every answer has BIOS. So then it must be OS because without OS taking control, BIOS cannot take the spreadsheet process to running. So therefore, this is not correct. After BIOS, it must be OS. So therefore, I'll say 2 is not a possibility, 3 is not a possibility. I'm always doing logical thinking, right? Because it is the operating system that run other programs, right? How can program runs without operating system start running? Right. So then the operating system can decide which program to run. There's no guarantee that it's always the first spreadsheet and then web application, web browser. But there's a higher chance that it is spreadsheet and web browser because according to the explanation, it says uh, Amara has first click on the spreadsheet and then web browser. But sometimes when you click at very close interval, sometimes the second program may run given the attention more before the first program because there's no guarantee in OS environments. Okay, but in general, there's a higher chance that first it is spreadsheet and then web browser. Okay. But anyway, I don't need to worry about that because in all the remaining answers, it is first spreadsheet. So therefore, I don't need to worry too much about that. Right? And then it says web browser, but this one says OS. Right? So remember, now in order to do the context switching, OS need to come and do something. So therefore, context switching is done by OS. So therefore, before the other program runs, the OS need to do a bit of things. So therefore, I prefer OS come into the middle. OS come into the middle. Anyway, other answers also OS is there, but this answer OS is not there, but OS is also running. Right? So basically, OS come to the picture and ask web browser to run. And then again, OS come and ask spreadsheet to run. Assuming that only these two processes are there, maybe some other processes are also there. So therefore, I prefer the first answer because OS, then the web processor, then OS, maybe again spreadsheet, and so on. So this is my preferred answer. Okay. So here, straight away, after spreadsheets, the web browser is running in both the cases, which of course you can think like that if you forget about the OS. But because OS is also in the picture, I prefer the first answer. I prefer the first answer. Right. Let's double check what is the answer. Yes, examiner has taken one. Is it clear? Any doubts? Any doubts? Anything you want me to explain further? Don't worry. We have enough time. Okay. Because other papers we can do fast as well. So this is where you need to clarify things. Okay. Right. So if you don't have any questions, we'll move on to 16. Which of the following statements are true? Right. It looks like this is related to security. A firewall acts as a packet filter, inspecting all the packets entering a network. Yes. So the firewall is at the very edge of the network, just after the router, just inside the router, and it filter or analyze each and every packet, incoming packets and outgoing packets. Incoming packets for security, outgoing packets for control. We can use firewall to control the use of internet by our employees and so on. And we can check to which sites they are visiting. Maybe we can block. No, you are not supposed to visit Facebook during work hours. One main task is analyzing the incoming packet to check whether there are any possible virus patterns, possible DOS attack, and so on. So I'll go for A. Malware. Malware means something like vicious software, right? Doing vicious things, bad things like virus, worm, Trojan horse, adware. Malware that misleads the users by disguising itself as a standard program is termed as Trojan horse. Correct, right? So Trojan horse is it pretend or actually it does good job, right? Like maybe you download pirated copy of Photoshop and it does the your Photoshop, right? But at the same time, it is doing bad things. But original Photoshop is not supposed to do bad things. But this corrupted or the pirated software is doing bad things also, like collecting your password, sending your credit card details, or maybe after sometimes it corrupt your hard disk. Right? So that is what is mean by Trojan horse. Okay, Trojan horse. So this is correct, right? We discussed that. A strong password should have combination of uppercase, lowercase, numbers, and symbols of sufficient length. Yes, strong password must have all this. It doesn't mean that it is a must, but that is the best practice, and some systems even enforce you to do that. Otherwise, that your password is not accepted. So for me, all are correct. Right? All are correct. Yes, 15. 5. 17. Now you can see this is like easy part, right? Little bit easy, not fussy. The first few questions were not difficult but fussy. But now it's pretty standard knowledge. Which of the following statements are true? Security. We discussed security, I think last week, right? Network security. Not last week. Sometimes back, right after doing computer networks. One of the users of encryption is ensure confidentiality of transmitted data, obviously. So what are the objectives of security? Can someone tell me? What are the key objectives of security? Objectives, not how to do it. Number one, availability. Number two, anyway, you can write it in your order. Confidentiality. Another one, integrity. Last one, Non-repudiation. So availability means your systems and resources must be available to genuine users. That is why we want to prevent virus attacks. Hackers come and destroy your data because then availability is compromised. Second one, confidentiality. So some data must not be revealed to third parties. Some are for security reasons, some for privacy, right? Like password of a user account. If it is a banking application, others must not be able to view your account details. If it is a email application, only you are supposed to see your emails. Others must not be able to read your email. Confidential. Then integrity means your data must not be changed by third parties without knowing or the consent of the user. Integrity. Data must not be altered by vicious parties. And non-repudiation means when you do something, when a user do something or does something, he or she must not be able to claim that never done. So done cannot be claimed as not done. Not done cannot be claimed as done. So that is why we need log files and so on. We log all your activities so that we can double check whether you have done it or you have not done it. So then if you have done it, you can't say not done. If you have done it, if you haven't done it, you can't come and say I have done because the log file must have that. Okay. Right. One of the use of encryption is to ensure confidentiality of the transmitted data. Correct. Every user needs to have a pair of dissimilar keys when using asymmetric key encryption. Yes, that is what is asymmetric, not symmetric. Two different keys. Okay, but do we need every user needs pair of dissimilar keys? Now read very carefully. Every user needs to have a pair of dissimilar keys when using asymmetric key encryption. Say I have a website, right? You guys must be able to access my website securely and create accounts, access it, and right. Only your password must be visible to you, not to anyone else, so that they can't log in like you. Now, this is my record. This is our application. Now, do we need that everyone has pair of keys? That means I have a pair of key and say you have X has a pair of key, Y has a pair of key, Z has. Say if I have 100 users, each and every user need to have pair of keys. I don't think so, right? So not every user needs to have pair of keys. Of course, that is if every user is having their own systems, right? So therefore, that is not something I like as answer. Okay. Because it says every user needs to have pair of dissimilar keys. For example, we access different applications, right? Do you have any pair of keys with you? Definitely no, right? I don't have any key pair because of course, I have key pairs for our our web server because I'm doing some development. But in general, right, you guys don't have any key pairs, right? Still you access it. So therefore, I'll say no for this because not everyone need key pairs. Maybe we need one key pair for asymmetric keys. Say when we access something like Gmail, so the Google has created a key pair, one key pair, just one private key and public key, and they have kept the private key in their server, and they are giving this public key to everyone. It's the same public key that I get, you get, anyone else get when you try to log into Gmail. So therefore, they just need one key pair for Gmail, one key pair for Facebook, one key pair for, say, if you are using Sampath Bank, so all the Sampath Bank customers who access EB's e-banking system, just one key pair generated by Sampath Bank, private key is with them, public key is sent to our browser. Of course, we don't see the public key, but actually the public key is sent by them to our browser, and browser encrypting using public key and sent to the Sampath key web server. And Sampath key web server has a private key so that it can decrypt and see. Okay. So therefore, I will not go for B because it says every user needs to have a pair of dissimilar keys rather than every application. Actually, every application need to have a pair of dissimilar keys. Okay, that is my way of logic. Right. Let's see. Users must share a common key when exchanging information using symmetric key encryption. No, in symmetric key encryption, there's no common key. So just you have one key, just one key that your sender and receiver must keep it as a secret. Both sender and receiver know that key, but make sure you don't give it to anyone else. Okay? Don't share it with others. But when asymmetric key cryptography, then we have a common key. Say Google has shared their common key or the public key to each of all of us or our browsers, right? So it is the common key, or that is why we call it public key cryptography. Another name for asymmetric key cryptography is what? Public key cryptography, because we have public key and private key. Private key is with the key generator or the receiver. Public key is given to any app or browser that try to access that application. But in private key cryptography or symmetric key cryptography, we have only one key, right? One key, not two keys. So that key is a private because it must be kept secret among the two guys, sender and receiver. So that is why it is bad, because you need to share your secret with the sender. So that is why we use only that approach when we trust the sender, like our two branches, branch and head office, where that system administrator I can trust. But not for general applications like banking applications, social media. Then we go for asymmetric or public key cryptography. Okay. Right now, this wording is very confusing. Users must share a common key. It says users, right? Not just sender and receiver. So this answer can go any here and there because wordings are not very good. Now this is another fussy question, but it says users, right? So therefore I'll say no. Usually shared key means public key, but in symmetric key encryption there's nothing called public key. So therefore I'll go for A only, but it can be debatable due to C. The way C is presented, but I feel like still uh, A is the answer. Only A is the answer. Okay. Oh, that is, you can see, examiner has taken 5 as the answer. Examiner has taken all are correct. Okay. So that is pretty debatable answer. Okay. So let's read it again just to double check. Right. Examiner's answer is what? 5. Okay. Let me double check the answer again. Yeah, 5. One of the use of encryption is to ensure confidence. That is, there's no doubt about that. That is correct. Every user needs to have a pair of dissimilar keys when using asymmetry. Maybe the why examiner has taken this, maybe examiner thinks that everyone want to communicate with each other, but that part examiner has not mentioned. If so, yes, say something like this. So A want to communicate with B, A want to communicate with C, A want to communicate with D, B want to communicate with C, D, and A. C want to communicate with A, B, and D. D want to communicate with A, B, and C. If everyone want to communicate with each other, that part is not there, right? If so, yes, every user needs to have a pair of keys, but that part is not there, right? So that is why I did not take it. But maybe that is what is in the mind of the examiner. That is very unfair. Okay. And here it says users. Then they should have mentioned, examiner should have mentioned it as how? Sender and receiver must share a common key. Actually, it is again very wrong to say common key. Yes, it's common, same key. But when we say users, say if you have 10 people communicating with you, you need to generate 10 different keys because otherwise what this guy sends can be hacked by this guy because this guy knows the key that can decrypt this encrypted data because it's the same key we use to decrypt. So therefore, it's very debatable for me. But anyway, that is part and parcel of life. Okay, things are not always very clear, right? Maybe this question is taken from some other past paper, exam paper, and so on. Okay. I like to put this into Google, Chat GPT because I just want to check whether Chat GPT get confused. But sometimes what happens is these questions are taken from some other papers also. In that case, Chat GPT has a context. Okay. But anyway, I like to check whether Chat GPT get confused or not. Okay. So I'm interested in that kind of things also. Okay. I got really not confused. I got wrong answers because my thinking was different. But now let's do an interesting thing that just let's put it into Chat GPT and check. But maybe Chat GPT get the same answer as marking scheme. I am happy if Chat GPT get the same answer as my answer, but possibly Chat GPT get all correct. Okay, right? You can see Chat GPT has better insight of these words. That is why we say ChatGPT is smarter than humans, okay? Right? Smarter than humans. Maybe another reason is ChatGPT may have seen this question in the internet. And you know that these guys have terabytes of memory, okay? But anyway, uh, so ChatGPT also says, okay, let's go all as correct, though the wordings are fuzzy, okay? Wordings are fuzzy. Anyway, the wordings are really fuzzy, okay? But there's no doubt about that A. But this should be then everyone need to communicate with each other. Okay. So this common key must be the private key there. This must be a common key among these two only. Right. Anyway, still it's terrible wording. Okay. Right. Question number 18. Which of the following is considered as erroneously received by in an even parity system? So remember, if it is an even parity system, you must have even number of ones. If you get odd number of ones, you know that there's error. If you get even number of ones, it doesn't mean that there is no error. But some, but if it is odd number of ones, there's definitely error. Okay, right. So it's super easy now. You just count how many ones are there. Right here, 1, 2, 3, 4, correct. 1, 2, 3, 4, 5. This is wrong. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So this one is the erroneous data. Others can be correct or erroneous. We can't guarantee, but definitely this is erroneous because we have odd number of ones. If it is even parity system, they should have add one or zero to make it one. Maybe they have added, but something has corrupted. Right, I'll go for four. Right, four. Right, 19. Network related question. Match the devices labeled from A to E to the corresponding descriptions labeled from 1 to 5. Right. So remember that next class we are going to do the structured essay and essay paper 2023 while we are doing e-business. Okay. So be prepared. Okay. Do that and come. Right. At least do the next 20 question or the rest of the MCQs and come because first we want to finish the MCQs. So then it will be more productive for you. Right. We have the client, hub, router, server, switch. Remember the OSI architecture? Physical, logical link, network, transport, session, presentation, and application. So remember switch is hub is physical layer device. Switch is logical link layer device. It works with MAC address, data frames. Router is a network layer device. It can work with IP addresses, data packets, IP packets. Okay. Client and server are related to applications like web applications and so on. Okay. Right. So let's map it. Stores network programs and data files for the users to access. So that must be probably server, right? But if you get a better answer later, we will change it. Don't worry. For the time being, so server stores the files and other things like your HTML files and so on, like a web server. Connecting devices between LANs and wide area networks. LAN to LAN connection is done by routers, right? Subnetting, right? LAN to LAN or sub LAN to LAN is done by routers. When a message is received, this transmits it only on the port to which the destination computer is attached. So that is called switching because hub broadcast. Here port means physical port, not that port number in transport layer. So when you have physical ports, when you get a data frame, switch it to the correct physical port because it has the MAC table. MAC address, physical port number. Your data frame has the destination MAC address. And when a message is received, this transmit only to the port to which destination computer is attached. That is called switch. Request services and content from the other computers. That is a client. When a message is received, this broadcasts it on all ports to all attached hosts. That is hub, because hub is dumb. Hub has no idea about addresses. Super easy question, right? This is a typical question. So therefore answer is once you find A, you are done because you can see five different answers, right? So once you find A, just you need to double check. Client A to 4. So this must be answer, but let's double check. B to 5. Yes. C to 2. Yes. D to 3. Server. What happened to server? Yeah, D to 1. D to 1, correct. And E to 3. Yeah, E to 3. Right, E to 3. So answer is fourth one. 19th, fourth. Yes. Right, 20th question. Right, 20th and above we'll do in the next class because we have a bit of network questions and security questions and so on, right? Right. Now, how is your comfort level about this paper? Right. Okay, this is not a difficult paper. This is somewhat easy. Actually, last year paper is the really challenging paper. Okay. Right. So we have come to the 19th question. That is almost half. But this is our first MCQ discussion. Therefore, I did it slowly, but we will make it faster and faster. Okay. Right. So next 20 questions, we may do it in the next class. But in the next class, first we will do the e-business, maybe 1 hour. because there will be business questions also. And then we'll look at the rest of the MCQs. Okay, most probably we'll go like that. Okay, right. We'll stop at this point. Thank you.
Thank you, sir.
Okay, you're welcome.